warehouse and BI flow. This is a generic picture. Structured data move to warehouse using ETL process from their semantic components from their reporting. Structured data move to warehouse from there to semantic components to reporting. And a bit low level I explained in the down. What I explained, these are source systems and we call it as OLTP systems. These are OLTP systems and where we have live data. From there, we move data into another area. This is a stage area. Some companies, they move into ODS. Some companies, they move into stage, etc. This is one more stage. Stage 2. We consider this one as a stage area. This is stage 2. And from there, where we are loading, here is a place we have data warehouse. On the data warehouse, we created some cubes. On the data warehouse, we created some cubes. Tabular cube, comma, multi-dimensional cube. From there, reporting happening. Finally, this is presentation area. So ignore about this, but the data flow is OLTP to ODS, ODS to stage 1, stage 2, warehouse, semantic model. These are cubes and cubes to report. This is end-to-end flow. Understand? And the same thing I explained. You want to write this part? Write this part. No need to write moving forward. Today only you need to write. Moving forward, no need to write. Now, come to this. This is the one I explained it. Correct? Now, SSIS. What is SSIS? SSIS stands for Integration Services. And here we have 3 services integration. How many services integration?
3 services.
And many people feel SSIS is an ETL tool. It's not an ETL tool. It is an integrations tool. What it integrate? First one, ETL service. Second one, Windows administration service. Third one, SQL Server administration. 3 types of services. This is a major service. That is what people call IS as an ETL tool, but it is not an ETL tool. It has ETL. It has Windows administration. It has SQL Server administration. Total 3 operations. Are you clear? Now, analysis services. What it does, it converts your normal data into decision-making data. And decision-making data in 2 ways. One is 2-dimensional, second one multi-dimensional. And 2-dimensional is called tabular, and multi-dimensional is called cube. You are reading it, but you are not understanding. You people are continuing focusing on reading, not for understanding. So in AS level, what are we doing? converting into tabular models or converting into cube models. And this is for simple analysis, corporate analysis. What
AS only deals with modeling.
Perfect. Modeling. And RS is for presentation. And DQS is for quality assurance. What are the operations we are doing here? Profiling, scrubbing, matching, cleansing. There are 4 quality operations: profiling, scrubbing, matching, cleansing. So what are the differences? I will tell you, don't worry. Now what is the next one? MDS, Master Data Service. It manages metadata or master data. We call it as important data, important objects data. Important objects data. I will show you how do we work with MDS also. Don't worry. Now, what is BIS? There is no SSAS. If you open the analysis services, it will show you SSAS BIS, Business Intelligence Semantic Model. And this model only helping the companies to perform personal analysis, team analysis, corporate analysis. Simply self-service BA. Self-service. Then what is Power BI? It's a separate component of Microsoft, inspired and released from SSRS. So Power BI equal to RS plus Power Query, Power View, Dashboard analysis. Now, write 2 important points here in case you are interested, right? Otherwise, listen to it. DQS. It is doing profiling. Profiling means data screening here. Next one, scrubbing. Scrubbing means data changing. Cleansing. Cleansing means removing inconsistent, wrong, junk, unwanted, and redundant data. So this removal is called cleansing.
Unwanted mistakes,
Unwanted and redundant data. Redundant data. So this removal is called cleansing. Hope you guys are clear with the basic components understanding. Now, we will go to the next one. See guys, this is the technical sheet we are using in our company for less than 7 years of experience, more than 7 years, even for project managers. If you are into business intelligence and you are a project manager, in this industry project manager, for you also the below topics are compulsory. First one, warehousing skills. Second one, modeling skills. And later, finally, project management skills. As you're entering into this one as a manager, so you need to have good knowledge on the warehousing fundamental, modeling fundamental, and this. Next, that DWB architect, and you're trying as an architect. For architect also required, but in detail knowledge. So architecting skills last. The first one, warehousing fundamental, modeling, not fundamentals, in detail knowledge on the warehousing and modeling mandatory skills. And then this. And you're trying as a business analyst. You people are suitable for this. And what you need to know. First one, second one, and you need to have additional one more, basic SQL query knowledge. And then your ETL reporting. Finally, business analyst skills. Are you okay?
But this business analyst skills may be coming with
These are
experience.
no. These are your yes, your component knowledge. Your component knowledge. Good. And those two topics I will cover slowly. Warehouse and modeling. Don't worry about that. Next. We partially discussed data warehousing fundamentals in the last class, partially. And today I will complete the first part, warehousing fundamental one. The first theoretical topic I'm closing, and tomorrow we will start SSIS. The other day onwards, it will continue. And on Saturday, we will go for data modeling fundamental. So today, warehousing fundamentals, I'm going to close. Tomorrow, day after tomorrow, IS. And Saturday, we'll discuss data modeling so that we are good with IS initiation as well as important fundamentals. Warehousing fundamentals, for whom it is required. Every warehousing and BA professional require this knowledge. I explained about data, information, OLTP, ODS, OLAP, data mining. These all words I explained. And you will get this material tomorrow. Online people as well as offline people. And you can go and watch it. I'll explain you again these terms, concentrate. Many important real-time things also I'm going to cover. Focus on it. Take this only. With respect to warehouse, this is a warehouse. With respect to warehouse, whatever you are passing, that is called data. And we call as source feed. Source or data feeds. So day-to-day data information is data with respect to warehouse. And whatever you deliver here, the reporting level, this is called information with respect to warehouse. Then what is warehouse? Huge storage suitable for decision making. If any database, you use it for huge storage and you maintain huge storage and use it for decision making, that is called warehouse. So data source, information warehouse. Then what is this? I used a word called ODS here a couple of minutes before. What is ODS? ODS is operational data store. These sources store data, that is live data, milliseconds also data available. Whereas if you maintain a copy from this, every 3 hours, every 4 hours in a day, and you are maintaining a copy, and this is called data store for live, data store for not exact live data, 3 hours delay, 4 hours delay, 5 hours delay available. So ODS systems are near live systems, near real-time systems. Near real-time systems. So in companies nowadays, they're maintaining ODS systems and they consider as stage systems to maintain near live data. 5 years before, 10 years before, companies used to maintain ODS systems with a delay of 1 day. 1 day delay, 2 day delay, 3 day delay. Nowadays, they're maintaining ODS system with 3 hours delay, 4 hours delay. Like this. How is it suitable? Majorly, this is the input to warehouse. In this industry, how is it suitable? Input to warehouse. So you need not contact source system to get the data. So you can directly pull from ODS, and that is happening too. Correct? And the process which you follow to move data like this, data to information, that is called OLAP process, online analytical process. The methodology which we use to do this is called BA. So BA uses OLAP process to convert data as information. That is why BA I concluded last class. It's a process of gathering the data, converting the data, presenting the data. Gathering, converting, presenting. Sir, I heard a word called mining. What is that? I explained about analysis services in a simple way. It converts normal data into decision-making data. Normal data into decision-making data. Perfect. This decision-making data is cube data or tabular cube data. One more, mining data. Which data? Mining data. So our AS can perform cubes creation or mining models creation. But rarely people use mining model. That is why always we use the word cube. But AS has the capability to create mining. Then how these are helpful and how this is helpful? Cubes are helpful to understand current. See the terminology. Current nobody can analyze, only understandable. And past analysis. You want to understand current and you want to analyze past, then go for cubes. Whereas mining will help you to predict future. That is why mining models are knowledge discovery and analytical models. Mining models are knowledge discovery and analytical models. It will discover knowledge. So there's a thick difference between analysis and mining. Analysis talks about current and past, and mining talks about future. Mining talks about future. Shall I go next? So these are the basic words which I mentioned here, and I explained all that stuff. Now, the next one. This is okay. Data warehouse and various definitions. I explained only one definition. What is that? Huge storage suitable for decision making. But how do we construct? Not all huge storage areas are decision supportable. Not all huge storages are decision supportable. Then how do we create? For that, there are different scientists, leading practitioners. They mention different principles, and we call it as characteristics. What are those? First one, and first warehousing expert and scientist in MAN. He specified, if you want to construct a proper warehouse, follow the below protocols. Ensure subject orientation in the warehouse level. I know it's a bit tricky and confusing on the very first day, but mandatory. The fundamentals are fixed fundamentals. If you read it one or two times, you will understand easily. Anyway, I'm sharing the video. Please go through that. Clear? Good. So if you don't understand this, you cannot work with it easily. So one of our student joined as Powerbi developer in one company. He started learning MSBA. After 20 days, he joined Powerbi in the same institute from me only. MSBA looks a bit complex than Power BI. Power BI is very easy, drag and drop. Even customers can generate their own report. Customers and users, non-technical people can generate their own reporting with Power BI flexibility. He focuses on Power BI. Opportunities are more, but the problem is no one will help you in the company once you get the opportunity. That is a problem he is facing now. I told him, learn MSBA strongly. It is safer side and safety for you. And so although you join in Power BI, if they don't have project or if they don't have project, they will ask you to work in MSBA, point one. And MSBA components compulsory to work with Power BI. He did not listen my words. Somebody told him, learn Power BI and try. He paid fee for Power BI and MSBA. And last night, I asked him, how is your job and where you're working? See his reply. He is a candidate. This is WhatsApp. So, good sir, Mumbai got job yesterday night and Power BI facing a big difficulty. I am only Power BI resource at present and need to migrate SSRS and ClickView reports to Power BI. So many projects are like that only. This is students. That is why I told you yesterday. If you learn only Power BI, you face issues. See?
When I guess you told me.
Yes, you told me the same thing. So focus, try to understand all the things first. And he watched many videos of mine and internet. And he studied many FAQs. But the only problem is he haven't studied anything systematically. He never tried to know the subject. He always need practical. That's a problem. Okay, ignore that. But you learn properly. Come to the topic. So according to Inman, prepare a warehouse which is subject oriented, integrated, time variant, and non-volatile. The warehouse should have subject orientation data, and data should be integrated data, and time variant data and non-volatile data. 4 features. These are called 4 principles or 4 characteristics. What do you mean by subject orientation? These are your day-to-day systems. Your order processing, one area or one application. Consumer loan, one area, one application. Customer billing, one area, one application. So day-to-day level for each operation will have one application. Whereas warehouse level, we don't do like this. Total all orders related stuff in one area. All claims related stuff in one area. All account related stuff in one area. These are called subject areas. Some people call it as data marts. Data warehousing level maintain data marts or subject area data. So day-to-day level, application based, process based, and here complete task based, complete functionality based. And no 2 subject areas will do same operation or relative operation. See, product will do a different operation, sales will do different operation, account will do different operation. This is subject orientation. So prepare a warehouse with subject orientation first. Second one, integration. Your business happening in different countries, different locations. So you will find different currencies, different naming standard. But while you move into single area, single warehouse area, try to ensure common naming conventions, common currency conventions. Something like this. These are called as standardization. Don't think integrated means integrating data. While integrating, ensure standard naming conventions, standard currencies, standard codes, standard process. That is called integrated. So single subject areas, integrated data. Next, time variant. What do you mean by this? Along with time, only load the data. Or each and every record should contain timestamp. So that current data you can understand, past data you can analyze, future data you can predict. Future data you can, these three possible when if you maintain data based on time. But which time is required, sir? And what kind of time hierarchy we have? Remember the hierarchy. Date hierarchy is day, week, fortnight, 15 days, month, quarter, semester or half year. This is a hierarchy, and this kind of terminology only you find in the BA level and data science level, artificial intelligence level. BA, data science, artificial intelligence level, you find only this terminology. So semester, year, leap year, and quad year, decade, century, like this. This is called date hierarchy. Which hierarchy? Date. Now come to time hierarchy. Hour, minute, second, millisecond, etc. This is time hierarchy. Sir, which one is good for the business? Now, almost all the companies maintaining day-based data. So daily loading the previous day data into the warehouse. Mostly companies maintain, and this is recommended too. Because as part of date, this is a low grain. This is a terminology which is important. Interview question or project question. What is the grain of your project? What is the grain of your project? You can tell them, my warehouse has multiple tables with multiple grains. Some tables, weekly load tables. Some tables, monthly load tables. Some tables, yearly load tables. But my low grain is day. Low grain is day. So if you maintain day wise, then week analysis, fortnight analysis, month analysis, upper all possible. Whereas if you maintain month wise, lower not possible, only upper possible. So lower possible. So in this picture, according to this is not possible. This is possible. Okay. Example: John sales. John 2009 sales is 30,000. Assume. If I ask you, John 23rd sales, no answer, because January month wise you maintain. Or January first week sales, no answer. So that is why if you maintain month wise, these are not possible. These possible. Clear? Clear. Now non-volatile. What do you mean by non-volatile? Non-volatile in the sense no change of data. And anyway, we don't do that, but this feature will help you to maintain better history in the warehouse. For example, when I move to multiple locations, maintain all the locations in the warehouse so that you can answer first location, current location, last 2 months locations, last 6 months locations. So this kind of feature you want to, so this kind of answers you want to provide, maintain data with non-volatility. So total how many features we have? 4. First one, subject orientation. Second one, integration. Time variant. Last one, none. Are you okay? Next. So data granularity. You can see daily load tables, monthly load tables, quarterly load tables. And what is grain? I mentioned very clearly. Now data mart and types. Unknowingly you studied it. Data mart is a subject area, functionality area, task area. That is the right answer. But some people speak like this. Data mart is subset of warehouse. subset of. I'm not saying that is wrong, but partially correct. Any specific functionality area, any specific subject area is called as a data mart. Data mart, Walmart, D-Mart, K-Mart. Those are retail business substores. Retail business here also. Data mart is a special purpose subset of enterprise data for particular operation. If this is your warehouse, from there if you construct a data mart, that is a dependent data mart. On top of warehouse, if you construct a data mart, that is dependent. I mentioned here, created from the warehouse. Whereas these are operational systems, that means day-to-day systems, OLTP systems. From there you create a data mart, that is independent data mart. From operating systems, if you create independent, directly from the warehouse, if you create dependent. What is logical you can't understand, later I will tell you. Now, practically, how do we create a data mart? Theoretically, okay, anybody can answer. Even when we ask in interview, what is data mart and how many types available? People speak like this. Data mart is a subset of warehouse. We have two data marts, dependent, independent. That is okay, partially. But how do we create practically? From warehouse, majorly we create views. What do we create? Views. And most of the data marts in the real time are views, complex views. I created 2 to 3 data marts in my lifetime. One data mart took 6 months of time. One view took 6 months of time. One data mart 3 months, one data mart 1 month. 3 data marts I created in my life, and all are on views. But one more data mart we created. It's not an exact data mart, processed object through procedure. Processed object through procedure. Practically, how do we create? By creating a view. By creating a view. Sir, from the warehouse, a view creation makes sense. But what about here? From operating systems, how do we create? Here, we create a data mart through a separate physical database. Separate physical database and physical instance. Physical instance. Because you are getting data from different databases. So on different databases, you cannot create a view. View is always on single database. Single database. Next. I'm talking about here database heterogeneous or homogeneous basis. This is Oracle, this is Teradata, this is SQL Server. You can't create a view. You need a separate physical database. But you are creating a view. Sorry, you have only one database like SQL Server or Teradata or DB2. You can create a view happily. Now you ask me.
As far as my knowledge is concerned, we cannot store data using a view.
That is true.
Maybe, but when we create.
I'm not telling data mart contains storage.
Okay.
You're not getting me. Data mart helps to implement a functionality.
Okay.
It does not mean it should have storage. Structure is sufficient. Okay. And view has a storage. That is materializer view. There is a view called materializer view which has storage. We use for analytical purposes, designing aggregates, designing analytics. These purposes we use materializer views in database level. SQL Server, Teradata, Oracle, all databases have materializer view concept. Warehousing level materializer views are highly helpful. No problem. Remember, views are 2 types. One is regular, your academic views, what we studied, read-only view, modifiable view. But on top of it, one more view, we have materializer view, which has data, which can store data, and that is suitable for analytical purpose and aggregate operations purpose, for frequent reporting. Next one, data warehouse approaches. There are 2 approaches. One is data marts to warehouse. We can construct small data marts first, from there to warehouse. This is called Kimball approach, bottom-up approach. Second one, warehouse to data marts. This is called Inman approach, top-down approach. There are 2 approaches. Each and every warehousing project contain either of the approaches, either Inman or Kimball. But 95% projects using only Kimball approach. Why and what is the reason? The reason, first one, this one, cost effective. You can slowly construct data marts and then go for warehouse. Second one, resource effective, cost, resource, and memory and many effective. That is why we prefer this. And your project is following waterfall approach, waterfall life cycle, and a standard project, then go for this. But if your project following agile approach, so agile life cycle model projects, you will find Ralph Kimball, and waterfall model projects you will find in model. But some agile projects also using that is different case. And what are the situations? If you want to look into that, I mentioned here that approaches advantage, drawback, advantage, drawback. Please walk through it. Clear? Next, life cycle steps. Just I used a word, life cycle. Each project require a life cycle. Knowingly, unknowingly, every day we walk in life cycle. If you stay in apartment or flat or house, it follows a life cycle methodology. Even our human body follows a life cycle methodology. Similarly, a project also follows life cycle methodology. Life cycle methodology. Software development life cycle. High level steps, requirements gathering, analysis, design, coding, multiple. Design, coding, testing, implementation, maintenance, let us service level agreement. Service level, if you are working in a OLTP project where you have front end and back end, and you are the person to design front end, and you are the person to write a code which contacts database. But whereas warehouse level, 5 different layers available. Okay, ignore 2 layers, quality and metadata, at least 3 layers, important layers. So 3 layers follow 3 different life cycles. ETL people, ETL life cycle. Semantic people, semantic life cycle. Reporting people, reporting life cycle. So 3 different people, so 3 different layers, 3 different life cycles. If somebody asks you, could you tell me your life cycle? Ask them which life cycle, ETL or semantic or reporting. Because reporting life cycle steps are different, reporting life cycle models different. ETL life cycle steps different, ETL life cycle models different. So warehousing level life cycles are multiple. Warehousing level life cycles are multiple. Next, OLAP types. What do you mean by OLAP and OLAP types? Look at this picture clearly. These are your source systems. And this is your cube. Cube is a multidimensional object. Cube is a multidimensional object. Sir, what do you mean by that? Here we can keep one dimension data, product. Here we can keep one dimension data, time. Here we can keep one dimension data, customer. Here we can keep one dimension data, some organization. So multiple dimensions data you can place, and again as to that measures. That is why cube is called as multidimensional object. Okay, now coming to types. What do you mean by type? These are your day-to-day systems, and here is the place you are storing your aggregated data also. Anyway, data available, and if you keep your aggregates also in this area, that is called relational analysis or ROLAP. What do you call it? Your day-to-day systems, maintaining data as well as aggregates, then it is called as relational analytical process. Whereas if you move the data into a cube area regularly, either daily or weekly, and there you perform aggregates for your reporting or analysis, that is called multidimensional analysis. Multidimensional. But some companies, they are keeping data in this area only due to budget and other reasons, and only aggregates here. That combination is called hybrid OLAP, HOLAP. So relational area, you are keeping data and aggregates. Multidimensional area, data and aggregates. Combined, you are doing hybrid. And you observe your managers, your HR team using Excel sheets to analyze the data. That is called DOLAP. Excel applications, Lotus applications, these all support desktop OLAP. So relational OLAP, multidimensional OLAP, hybrid OLAP, desktop OLAP. Clear? Great. Now the last terms, data scrubbing, cleansing, profiling, merging. These are ETL terminologies. ETL, what do you mean transformation? The below said All operations come under transformation. Now merging, what is merging? We do merging in two ways. One is by using set theory. Second one, joining operation. Which operation? So multiple tables data we merge in two ways. One is set, second join. What is profiling? I told you today morning. Profiling is clearing the data, scrubbing, changing the data. We use many facial and body scrubs, cleansers. This is to eliminate, this is to change. Now, sir, this topic I'm able to understand. What are the questions we will find? So data modeling fundamentals are only those, and detailed one we will see later. And if you put below 3 years of experience, these are sufficient. But if you are putting more than 3 years, then something else you need to read. And we have that part also in the material. Later we'll discuss. For the time being, these are sufficient. First question: difference between day-to-day systems and overlap systems. Very clearly I mentioned day-to-day purpose, day-to-day process, points. And second one, overlap, purpose, process, points. What is data warehouse and how data warehouse available in the market? Difference between overlap and BA. Difference between analysis and mining. And how many types of decision making available in IT. And difference between OLTP and ODS. Next, OLTP, other technologies. So we call transactional systems, operating systems, enterprise database, business process systems. Can you describe ETL end-to-end flow? How many life cycles available and what kind of life cycle your project using? And data warehouse characteristics, all I explained. What is granularity, which grain your project has? And what is data mode and how many types available? How do we create data modes practically? How many types of warehousing approaches available, which approach your company following? And how many types of OLAP available, which is effective? And there are a couple of generic questions. Explain date hierarchy. Explain, that's okay. You have to, these two questions will answer in the closer session. What's the first one? Guys, you got two databases. Same size. Two databases, same size. 2 terabyte, 2 terabyte. How do you recognize which one is OLTP database, which one is OLAP database? You have two buildings, same size. On what basis you use one as godown, one as residential area? Size is same. So size is not the matter here. Internal structure. Godown contain less doors, less windows, less partitions. Whereas house contain many doors. So internal structure. So here OLTP you want to say it should be normalized. And OLAP you want to say it should be denormalized. Denormalized are OLAP systems, normalized are OLTP systems. Which systems? And one of my friend was unable to answer and he lost the interview as well. With a simple question. He was in the third round in a MNC organization and the manager asked, the BA manager asked, there are two databases, same size. How do you recognize which one is OLTP, which one is OLAP? He said history maintenance, more size, more records. He said, there is an answer. So the question has an answer. Same size. So no need to answer this. Please explain something else. That's a model. What makes the difference? Model. And next one. A warehousing project, what minimally required? First one, life cycle. Second one, compulsory warehousing project require a life cycle. Or BA project. An approach required, top down or bottom up. One data model required. One OLAP required. One principle required. So these all a warehousing project required. That is why we need to have minimal understanding on this. Got it? So 4 characteristics by Inman. There is one more person called Kelly. Kelly has given some more characteristics. Kelly has given some more characteristics. Later we see in the detailed discussion. This is brief, and below 3 years you want to put, or below 4 years you want to put, more than enough. But you should have strong knowledge on this. Clear? That's it. This is about